Hi, good morning. Today we talk about the crystal field theory. So we call it as CFT, right? So this theory is proposed in order to explain colors of complex compounds. Complex compounds का colors कैसे बनता है? How colors are being formed by the colors का coordination compounds is explained by this theory. And the major development by this theory is it considers the bond between the ligand and the metal is considered as purely ionic force of attraction है. Ionic attraction ही consider करना है आपको. This is considered as only ionic attraction. The concept of coordinate bond is completely ruled out by the crystal field theory. So ligands are considered as only point charges. So considering that negative ligands have negative charge, positive ligands have positive charge, neutral ligands have induced poles. It considers the induced poles present in the neutral ligands. And metal, of course, metal के पास positive charge होता है. अगर neutral भी है, so it should have induced poles in it. If both ligand and metal are neutral, so we consider the bond between metal ligand would be induced and induced type of attraction Ca. So there is no concept of coordinate bond, right? So this is crystal field theory. The major point is point charges. Ligands are considered as point charges. Now we shall talk about d orbitals. So d orbitals, we know that we have dxy, xy, dyz, dxz. So these are the 3 d orbitals, and remaining 2 are dx squared and y squared. Chalo, just we have to check the structures of these d orbitals, then we will go through the CFT. xy, dyz, dz orbitals में electron lobes are present between the respective axes. So this is x axis, this is y axis, and electron lobes are oriented in this fashion. So this is xy के बीच में है, xy के बीच में electron lobes है, that's why it's labeled as dxy. dyz orbitals में भी वही केस है, तो यहाँ लेबलिंग बदल जाएगा. The structure is dumbbell shape है. This is, let's say, z, this is y. So these electron lobes are present between these axes. dxy में भी वही केस है, z axis ऐसा है तो ये x axis लगना है, तो यहाँ पर, यहाँ पर, यहाँ पर, यहाँ पर electron lobes होगा. Electron lobes are in this way, right? So these are 3 d orbitals, and we talk about dx squared y squared. dx squared y squared देखेंगे जिसमें along the axis होगा electron lobes. So this is x axis, let us say this is y axis. तो x axis के along, y axis के along electron lobes है, so that's why we call it x squared y squared. डिफरेंस समझना है आपको इनके बीच में और इनके बीच में क्या डिफरेंस है. एंड द लास्ट वन इज डी जेड स्क्वायर्ड. डी जेड स्क्वायर्ड में भी जेड एक्सिस को कवर करते एक इलेक्ट्रॉन लोब होगा विथ 2 लोब्स, एंड सेंट्रल में एक स्पेरिकल electron lobe is found with the electron node across the junction of the 3 axes. This is dz square orbitals. So basis on these structures, the first 3 d orbitals are one kind of d orbitals, and these are another kind of d orbitals. This is the basis of our crystal field theory. So these orbitals are called as T2G orbitals. These are called EG orbitals. आपको डिफरेंस समझना है, ये समझ में आएंगे तो आपको स्प्लिटिंग ऑफ डी ऑर्बिटल बिकम्स ईजियर. डी एक्स वाई, डी वाई जेड, डी जेड एक्स में इलेक्ट्रॉन लूब्स आर प्रेजेंट बिटवीन द रेस्पेक्टिव एक्सिस. EG orbitals like dx squared y squared and dz square में electron loops are present along the axis, and this makes the difference in their two types of orbitals, right? So we'll see how the orbitals are being split out here in octahedral complex, right? So we talk about octahedral complexes. Octahedral complex में d orbital splitting, d orbital splitting कैसे होता है, right? So in octahedral complex ligands approach central metal along the axis. So this is the basis here, you should understand it, along the axis. And we have the orbitals having electron loops along the axis are dx squared and y squared. Last one is the dz square. Dx squared, y squared and dz squared orbitals have the along the axis, and these orbitals are going to get higher repulsions with the incoming ligands. Higher repulsions भी होगा and so as energy भी उनका higher हो जाएगा. So that means let's say this is the d orbital 1 2 3 4 5 normal d orbital है. This will be degenerated d orbital. So 1 2 3 4 5, this is degenerated d orbital. Now this d orbital, when ligands approach it, split into two groups. So one having two orbitals set, another is with the two orbitals set. So dx squared y squared and dz squared orbitals are along the axis. Ligand is approaching it along the axis. That's why these orbitals energy is increased. Let's say this is the zero line. So energy of it has increased here. How much? This is the difference, and इनका energy decrease हो गया. This is the energy difference. कितना एनर्जी डिक्रीज होगा इसका? -2/5 विच इज़ 0.4, नेगेटिव 0.4 del O बोलना चाहिए, अदरवाइज इट शुड बी 4 dq multiplied by 10, you convert into dqs. And energy of T2G, so these are the T2G orbitals, of course these are the EG orbitals. ये डिफरेंस कितना होगा? 3/5 होगा, प्लस 3/5 विच इज इक्वल्स टू 0.6 और 6 dqs होगा. सो दिस इज द crystal field stabilization energy. Now let us see the electron filling. So electron filling we talk about weak field की बात करेंगे. पहले we understand the weak field में electron distribution कैसे होगा, right? So let us say this is the D1 configuration. This electron comes up here. यहाँ आने के बाद उसको two choices है, either it should go here or it should go here. So it follows the Aufbau rule. यहाँ पर आ जाएंगे electron. D2 is going to enter here. D3 is going to enter into T2G. And the fourth electron will be in the dilemma. The fourth electron has two options. It should enter into T2G orbital and it should get paired up with this. This is the first case. Second case, it should enter into Eg orbital into unoccupied this. But the entry of fourth electron is decided by, entry of electron is decided by, entry of electron is decided by the pairing energy, decided by only the pairing energy. Now I will explain what is pairing energy. यहाँ पर अगर फोर्थ इलेक्ट्रॉन को यहाँ आने में एनर्जी कम लग रहा है तो यहाँ आएगा, यहाँ आने के बाद इसको क्या खर्च करना पड़ेगा, पेयरिंग एनर्जी, इसको पेयर करना होगा, इसके साथ पेयरिंग करना होगा, उसके लिए थोड़ा एनर्जी लगेगा। या यहाँ से ऊपर जंप करना है तो इतना एनर्जी आपको इनको चाहिए, अगर एनर्जी इससे कम यहाँ लग रहा है तो नीचे आ जाएंगे। राइट हियर, इफ पेयरिंग एनर्जी इज मोर देन splitting energy, the electron enters into Eg orbital. So weak field में वही होता है, the fourth electron comes up here, fifth also comes up here, and sixth onwards the pairing continues here. Sixth goes here, seventh goes here, eighth goes here, ninth goes and pairs up in Eg orbital, and so as 10th here. This is how the electrons are distributed. So I will write here one by one. For D1 configuration, it is T2 G1 Eg 0. For D2 configuration, it is again T2 G2 Eg 0. For D3 configuration, it is the same T2 G3 Eg 0. So now T2G is filled with one electron each. We will move to D4 configuration. D4 के लिए, so it should be T2 G3 Eg1. So for D5 configuration, it should be T2 G3 and Eg2. Now all the orbitals are occupied by one electron each. D6 should be pairing up. D6 goes and pairs up in T2 G3, so that T2 G3 becomes G4 and Eg is again 2. So D7 would be T2 G5 Eg2. So again T2 D8 configuration कैसे होगा, T2 G6 Eg2. So D9 would be T2 G6 Eg3, D10 would be 4. So we will write in a separate page. This is how the electron crystal field splitting looks like. So first electron comes up here, first electron यहाँ आएगा, second यहाँ आएगा, third यहाँ आएगा, fourth यहाँ आएगा, fifth यहाँ आएगा. So I will write in the same order, T2 G1 Eg0, T2 G2 Eg0, T2 G3 Eg0, T2 G3 Eg1, T2 G4, T2 G3 Eg2, then T2 G. अब जो सिक्स्थ इलेक्ट्रॉन है यहाँ आके पेयरिंग हो जाएगा, दैट इज T2 G4 Eg2 again it should be T2 G5 Eg2, again the same T2 G6 Eg2. Now the next electron will be entering into Eg3, that is 8th electron. Last one is going to be T2 G6 Eg4. तो पहले इसमें 3 भरना है, यहाँ 3 भरना है, फिर यहाँ से पेयरिंग करना है, फिर यहाँ से पेयरिंग करना है, राइट. So we will write it in a simple manner. So we have D1, D2, D3, D4, D5, D6, D7, D8, D9, D10. So D1 would be, we are talking about only weak field. So T2 G1 Eg0. सो दिस इज T2G2 Eg0. आपको एक एक ऑर्बिटल में एक एक फिल करते जाना है. Eg3, T2G3 Eg0. Now T2G3 Eg1, T2G3 Eg2. Next one goes pairing here, T2G4 Eg2, T2G5 Eg2 followed by T2G6 Eg2. Now the electron enters into T2G6 Eg3, T2G6 Eg4. This is how electrons are distributed, right? So this is D10, this is D1, 2, 3, 4, 5, 6, 7, 8 or 9. So these are the D electrons and how are they distributed. Now let us calculate crystal field stabilization energy. CFSC is equals to minus 0.4 into T2G electrons plus 0.6 into Eg electrons. Just add करने से आपको मिल जाएगा. So this is giving us 1 electron है, so obviously 0.4. This is minus 0.8. This is minus 1.2. This is minus 1.2 plus 0.6. Right? So this is minus 1.2 plus 1.2. This is again minus 1.6 plus 1.2. This is minus 2.0 plus 1.2. This is minus 2.4 plus 1.2. This is again minus 2.4 plus 1.6. So this is obviously minus 2.4 plus 2.4 होगा. This is minus 1.8 आना चाहिए, 0.6 into 3. So this is how you calculate the crystal field stabilization energy in a weak field case में. तो इसको ऐड करके भी डालेंगे, these are same. यहाँ कितना बचेगा, माइनस 1.2 बचेगा, this is 0. यहाँ कितना बचेंगे, माइनस 0.4 बचेंगे, so this is minus 0.8. So this is minus 1.2, this is minus 0.6, so this is again 0, right? So this is the crystal field stabilization energy. 6i, this is 2.4, 2.48. So this is how you calculate. All this is in weak field ligand. तो सबसे लीस्ट D10 कॉन्फ़िगरेशन है, so that's why D10 configuration is found to be stable. Even D5 configuration is also 0 है. ये दोनों electronic configurations are considered as the most stable electronic configurations, right? So we'll see it in the strong field. Strong field में चेक करेंगे ये कैसे होता है. Strong field is also the same kind of structure. So D1, 2, I'll write 1, 2 only. So 1, 2, 3, 4, 5. D configuration ऐसा है. तो strong field में T2G1 Eg0, D6 तक सेम होगा, T2G2, T2G3, T2G4, T2G5, T2G6. बिकॉज स्ट्रॉन्ग फील्ड है, सारे नीचे फिल हो जाएंगे. ऑब्वियसली ये कितना हो जाएगा, 0 ही होंगे. Eg is always 0 because all the electrons are entered into that orbital, right? Next we talk about D7, D8, D9, D10. So D7 में T2G Eg में, अब ये तो 6 ही रहेगा, T2G6, क्योंकि it is already full with 6 electrons. So the seventh electron should come up here. This is going to be Eg2, this is going to be Eg3, this is going to be Eg4. This is how you calculate the distribute the electrons. Crystal field stabilization energy can also be calculated here. So this is minus 0.4, this is minus 0.8, this is minus 1.2, right? This is minus 1.6, this is minus 2.0, this is minus 2.4. So D7 is minus 2.4 plus 0.6 equal to minus 1.8. So D8 is minus 2.4 plus 1.2 equal to minus 1.2. D9 minus 2.4 plus 1.8, so which is minus 0.6, and D10 would be minus 2.4 प्लस 2.4 विच इज़ ऑब्वियसली ज़ीरो कॉन्फ़िगरेशन होगा, ज़ीरो होगा. तो स्ट्रॉन्ग फील्ड लिगेंड में D10 कॉन्फ़िगरेशन का क्रिस्टल फील्ड स्टेबलाइजेशन कितना होता है? ज़ीरो होता है, बाकी सब लेस देन ज़ीरो है. सो दिस इज़ हाउ यू कैलकुलेट द क्रिस्टल फील्ड स्टेबलाइजेशन एनर्जी इन इट, राइट. Now we'll talk about how the colors are being formed here. So we'll go to this picture. The colors of the compounds are formed due to DD transition. How it explains the color structures of these compounds? Colors are explained here. So let us say I have D1 configuration. This electron absorbs some energy from the visible light having 400 to 700 nanometers and jumps into D orbital of higher energy, those are Eg orbitals, which comes back home by releasing some amount of energy here. Whatever the energy released here, that energy is going to have the same frequency, but we say that the light absorbed is complementary to light released by the electron. This process is called as DD transition. Due to DD transition, d orbital complexes complex compounds shows different colors. Okay, thank you.